Welcome to the SWD SCRI Projects Stakeholder Advisory Board meeting. Thank you again for joining us for the day 2 of our meeting. As I explained yesterday, our agenda today will focus on our research and extension plans for the upcoming year. Our objective leads or co-leads will present the plans, and then we will get feedback from the other team members as well as stakeholders. As the plans are being presented, if you have any questions or comment at that point, please raise your hand and Kayla will open the mic for you to speak. So at this point, we can go ahead and get started. I will show you sort of an outline of the agenda today. Here is this slide shows the agenda again. As we went yesterday, we walked through each of the objective. Yesterday focused obviously on the on reporting of activities in the past year, and today we will focus on our plans for the next year. And then in objective, I just wanted to let everybody know that at the end of objective 1's discussion, we will also mention that another meeting has already been scheduled to discuss use of AI in monitoring SWD. And I'll see if Gwen can make more comments regarding that meeting to ask everybody else to join in if they can. And then also, then we'll go just through all of the objectives one at a time. At the end, we will have open discussion on all objectives, and we will welcome everybody's feedback and comments on the protocols and plans. At this point, I would like to invite Hannah Levinson to start plans or presenting plans for objective 1. Hannah.
Hi, everyone. Thanks for coming back for day 2. So Hannah Barak and I are going to be talking about some plans we have for this coming year under objective 1. And hopefully you all aren't too sleepy from lunch, because we're going to ask for this to be pretty interactive. So just get ready and hopefully we can get some good feedback from you all. So again, here's the contact information for the Objective 1 co-leads in case you need that. And to quickly summarize from yesterday, just to make sure everyone is coming to this discussion on the same page. So we have a few topics that we already have plans for focusing on for 2024, but we are open and willing to make changes to this depending on how the conversation goes today. So the big one we're going to talk about is using what we're calling the decision tree tool to help decide management actions. So basically it's based around the filter method, where you're collecting fruit, putting it in salt water, counting the number of larvae, and depending on what you find, you can then work through the tree to help you decide what your management action should be that week. The other thing we're looking at alongside this decision tree is the impacts on beneficial organisms. So we're tracking parasitoid populations on these farms while we're implementing this decision tree tool to see if there's any changes there. And as Ash just mentioned, our Washington team is going to continue developing AI larval counting, and we could definitely set some minutes aside to hear more about that. And then our hope is to have more training material developed across this year, both virtual and in person, we are picturing, and trying to coordinate with extension agents, focused on helping describe the filter method and show how we use it, things we've learned, little tips or tricks to hopefully make it more effective. And then we can talk to you all and see if there's any questions still unanswered. So part of the interaction today is please, if you have comments or you want to bring up discussion topics, please raise your hand and Kayla can give you the mic. But also, we have a Padlet where we have specific questions set up for you all. And I can also share this link in the chat right here. So if you click on that link, it should take you to our Padlet. And we have a few questions just to get us started and hopefully get some conversation going. So the questions here, in case you don't have it up yet, are what new tools or methods presented today or yesterday are you already using on your farm? And if you have comments about your experiences, we would love to hear that. What tools or methods are you not currently using, but maybe you're interested in trying? It could be stuff we talked about yesterday, mentioned again today, or it could be something that we have not talked about yet. Are there tools that we didn't talk about that you are already using? We'd love to hear that as well, and maybe your experience with that. Are there tools you would like to learn more about? Are there things we talked about that you are not interested in using? We also want to hear that, and we'd love to hear why that tool may not work for you. Are there things you're interested in, but you still feel like you need more information before you could start using that? And that's something we could definitely implement into our planning for the extension training and extension events. And then if you just have anything else. So those are the questions in the Padlet. We'd really love to get feedback from you. But also, if you just want to chat live, I can take notes. You don't have to use the Padlet.
So Ash and Sarah, if you guys are okay with me screen sharing, I can screen share the Padlet and give people a quick orientation as to how to use this tool. And then there we go. Perfect.
Sure.
All right. So just a quick orientation for those of you who might not have used this tool before. If you click on the plus below a question, it'll open a field. And so the field has a subject section that's going to show up in big bold font. It also has a section where things will show up in littler font underneath. And so you can answer the question by clicking on the plus sign and then entering whatever response you'd like to add. We had a sub question associated with the fifth question about, or sixth question about, are there things you're interested in but not currently using? And so you can also reply to this by clicking on the add a comment part. There's some other fun interactive tools in here where you can upvote or downvote something that you agree with or disagree with that someone else has added. So if someone else has already captured your response to something, you can give it a thumbs up, or if you feel strongly that something is not correct or true for you, you can give it a downvote, but I would encourage you to add a comment if that's something that you want to expand on. So everyone should be able to edit this resource. So once you've clicked that link that's in the chat box, you should be able to get in and add your comments. And this will also be continuously available after this session. So if you want to leave this up and ruminate over the course of the rest of our conversations this afternoon, or if you want to come back to this later, you can bookmark it and come back to it and add more information. So I guess with that in mind, we can perhaps start off with our first question. And you guys are welcome to type into the chat box anything that you are currently doing. If you're not comfortable with adding it into the Padlet, or you're welcome to click that plus sign and add any additional things. So for example, what new tools or methods that we shared yesterday or in other parts of this meeting are you currently using? And Hannah L, I can't, oh, there we go. There's the chat box. Okay.
Yeah, I think a few people have joined on during our description of that. So there's the link again in case it wasn't in your chat box. If you still need the link, just let us know.
And I am seeing some people popping up in here. So there are some people who are able to navigate to the site. But similarly, you are welcome to put stuff in the chat box or in the Q&A. if that's a place you'd like to put your information and that's easier for you to find. I've got them all open in front of me on my window, and I'm happy to grab stuff out of wherever.
Or simply just, if you want to say something, simply raise your hand and we'll unmute and you'll be able to speak, and or somebody else will type in.
All right, our first comment, and I will say sometimes it helps to refresh the Padlet. It should auto refresh periodically, but if you're not seeing anything getting added, it's helpful to go ahead and refresh sometimes too. So I see our first comment to that first response is some orchards use traps and decoy. Protocols are in place at the warehouse for detecting larvae in cherries and blueberries. And larval infestation using a saltwater test to monitor if there's any infestation present. And the other nice thing about this is, unless you tell us your name, you're not going to be linked to these comments. So feel free to be frank if you want to say add something. These are you're just like little floating bug heads, little icons up there. And the flip side to that is, if you want us to be able to follow up with you, you should add your name. All right, well, let's open it up to that second question while people are continuing to work on the first question, which is, what tools or methods are you not currently using, but interested in trying?
Another aspect of this that would be helpful is if you already have, a few of you mentioned yesterday that you have protocols that you've used for years now at this point, and perhaps if there's a way that we could help you incorporate some of these things, if it would be changing your protocol, what do you need help in order to update those protocols? I know it can be hard to make changes to things that are basically just running themselves at this point. So that could also be something to add in there.
So something that's less time consuming for larval counting, perhaps AI or other tools that save time. And I will also say, you know, larval counting, how important is enumeration versus detection and qualification? So like little versus medium versus big, and then maybe bins of categories, less than certain numbers, more than certain numbers, as a time-saving measure for counting. So we got another comment to our first question, which is, we use traps in all our farms to determine when to begin spraying, and then use the salt test in their pack house as a report card for their IPM program. Thanks. I'm glad you like the work that's being done. So to that fifth question. So let's get some responses to number 3, which, how many larvae are too many? And that, I would love to see some responses to that question of how many larvae are too many, because when we started working on spotted wing, right, 1 was too many. And now are we in a place where we're more, as the decision tree framework that we're working with suggests, we're at a place where there is a number higher than 1, depending on the quality or the condition of those larvae. Monitoring for parasitoids and natural enemies in their area, and releasing parasitoids before they build up. Although it seems like parasitoids don't kick in until later in the season. Got it. So is there augmentative releases of parasitoids that could happen early in the year that might provide some earlier control. All right, so opening it up to question 3, and you can continue to add responses to any of these questions as we go on. Are there things that you're doing on your farm or at your operation that we didn't talk about, that people should know about, that you think are really great and might have some use for people beyond you? I always feel like I should tap dance in this moment because I'm sure people are typing and there's a lag in responses.
We were hoping for karaoke.
No, don't hope for that. You would not enjoy it. I asked my kids if I could sing in the car, and the response is, if you do it quietly. And similarly, as we're responding to that question 3, moving on to our 4th question, are there tools that you want to learn more about? Which ties into our question here. Are there things you're interested in, but you're not currently using? And what would get you over that hump? So we have exclusion netting that people are using. So to reduce infestation to very low levels. And this is also a good time to put anything in that is a no-go for your farm. This will not work for your operation. And it's something that we should keep in mind when we're communicating out to the community of growers that we're working with, that, you know, there's something we're talking about that's not a good fit for everybody. Frequent picking, yep, absolutely. Good sanitation and frequent picking. And we've got members of the team that have done some really excellent work on that. So under the things that you're not currently using, and what would you get over the hump? What would get you over that hump? It would be nice if growers were educated well enough to monitor, know thresholds to spray, and spray based on monitoring rather than spraying. But that has to be integrated in the strategies for other pests. And so, yeah, that is the mission statement for this whole grant, right? And some folks don't have sprayers, so insecticides are a no-go for them. So some of those non-chemical tools that are listed under our 3rd question are viable options. Yeah, and cooling, yes, absolutely. Pick your fruit frequently, pick it clean, keep it cold. And I am adding some comments from the chat box. So there was a comment in the chat box about decoy, something we haven't been talking about. And getting blueberry to the cold room as fast as possible helps kill larvae and helps keep the fruit firm. Yes. You guys are just making my heart grow 10 sizes because I feel like that was something that a soapbox I was stomping on. And so I'm really glad to see that. So as we design projects for next year, are there things you want to make absolutely sure we keep on our radar and we incorporate? Are there tools you want to learn more about? Other things you want to make sure that we're aware of and that we don't lose track of? So I'm going to suggest that we stick with this for another 5 minutes here or so, capture any additional thoughts you have. Then I would like us to go back to our proposed activities slide for objective 1. Make sure that we leave you guys with that information, but encourage you to keep adding to this Padlet over the course of the afternoon. And so as ideas come up, I would ask that you guys maybe keep a window open over to the side and add some content in here while we move through our other objectives. And then maybe that gives us a little space for the AI folks to chime in and talk about what that's going to look like. So we'll stay here for the next 4 minutes or so, just to allow you guys to capture any additional thoughts you have. But please keep your window open. Okay, so interested in hearing more results using Combi Protect or other emerging tools and introducing and maintaining parasitoids. And there was questions about if there's any project with the product called Drosomo from Certus in Canada or the US. And so I guess that would be, I don't know. I'm not aware of any. So I would ask other project team members to chime in there. Food grade gum. So that's an opportunity for Vaughn to give us some additional insight there. Do any of the project team members have a answer or input on this question over here under the anything else you want to share? Ah, here we go. The first tests were conducted in France, Spain, and Portugal on cherries and olives. So I guess I'd open that question up to anybody on the project team if you have any insights. All right, I am going to go ahead and stop share, but I am going to keep this open over here on my other screen. And so if I see some good stuff come up, I might amplify it in the chat box. And I encourage you guys to keep this Padlet open, continue adding things, continue adding responses, and I'll try to capture anything that pops up in the chat box over there as well. So we've got everything in one place. And so maybe we can go back to the slides to just re-amplify the activities we have planned for 2024. So Hannah, I'll turn this over to you and you can take us away.
Okay, yeah, so quick summary again, continue developing the decision tree tool, and I'll echo what Hannah said. Very happy to hear a lot of discussion about the cooling. That's definitely something we're gonna incorporate in all of the options that we provide in the decision tree. And we'll start thinking about what thresholds we could tell people. Still need to try that out. You know, that's a tricky one. We wanna make sure we're comfortable with putting numbers on the page, but we wanna provide the most useful tool for you all. Definitely going to investigate the impacts on beneficial organisms, especially parasitoids, and hopefully the decision tree can give us some insight, and implementing that in the field can give us insight there. And then quickly, I'll jump down to the bottom. Good to hear that you all would like to see more training material. We will definitely keep moving forward with that plan then, and hopefully make the fruit sampling more accessible to you all through training. And we do have plans for both virtual and in person. And then I think I will turn it over if anyone from Washington wants to provide more details on AI. We have plenty of time. Now would be a great time. Is anyone from Washington on?
Hi, if Gwen or Dylan are on the line, they'd probably be a little bit better, but just very briefly on the AI. We were able to train the algorithm to identify pretty reliably the second and third instars, but I was also assuming that the second and third instars were of less interest than the first instars. You were hoping to catch them before then. So we sort of looked at the quality of pictures we were getting and thinking, if we're going to get something smaller, we need a higher quality picture. And so step 2, after we finish the app that will just do this with a cell phone picture, step 2 is going to be to get a better quality picture that we can run the app on, and it can count all the stages. And that means photographing with even light on a flat plane in good contrast, I think, in order to do that, in a nutshell.
Thanks. That's a really great update. So yeah, maybe we just have a protocol explaining a setup to get really good lighting for everyone. And again, I want to reiterate why we're focusing on the first instar larva so much. I know that it's easier to look for the larger instar, and a lot of times in the warehouse, that's like a final check before your fruit go out. But what that means is that that larva has been in that fruit for quite some time. So if we're able to find the first instar larva, that's really early infestation. That's the beginning of the population buildup. So that gives you much more time to manage and try to control those populations, where if we're getting larger instar, that means that they've been sitting there for, it could be almost 2 weeks at that point. So it's really important to get the earliest instar possible. I know it's more difficult for you all, and it definitely takes more time, but that's what we're hoping to help you all figure out, is how to detect the earliest possible infestation levels. All right, so I think that we could end this Objective 1 section early, unless anyone has other comments really quickly, feel free to raise your hand, but otherwise we could keep moving on to Objective 2. And just know that you can still add to the Padlet. Please, if you have more thoughts as more presentations go on, please keep adding to it.
Yep, it will exist for at least the next year. And so anytime you've got that link and you have a burning thought about spotted wing Drosophila management implementation, that's the place to put it.
Okay, I don't see any other hands, so I'll say let's keep on moving to Objective 2.
Let's move on to Objective 2. And I think Binyan is gonna do the presentation, and Karina will be assisting her with any comments, feedback that we get, right?
Yes, exactly. Ash, thank you so much. And thank you, Hannah, for the nice questionnaire. It's great to us to know the growers' comments and interest. And I'll be sharing our research plans for the Objective 2, the economics of SWD for this coming year. So before I start to talking about our research plan, I would love to give a brief review of our goal and our work. So our economic analysis are mainly to support the identification and implementation of profit maximizing SWD management strategies that are of interest of growers and our entomologists. And we conducted economic analysis to evaluate different control strategies and make sure the strategies we are using are cost effective. And also we design and develop Excel-based decision tools to help growers to make the best economic decisions at your farm level. And for this new year, we have the following future plans for our objective 2. We'll keep developing the Excel-based interactive decision support tools for growers, and also we'll extend the work on economics of adopting fruit sampling to other states and other crops. And it's great to see growers are using the sampling in their farm and are interested in these strategies. So we'll keep working on this to see if it's profitable for growers to use this strategy in your farm. And also we are interested in evaluating the economics of pesticide resistance, given we already found this resistance issue in California, the key production for berries in the US. And also we plan to evaluate growers' responses for different IPM SWD practices this year. And so as one of our stakeholders, I mentioned yesterday, the exclusion netting decision tool we are developing from last year. So we are developing this tool for organic blueberry production in New York State. And in this tool, we have this partial budget analysis to compare the economic performance of using exclusion netting versus organic insecticides or versus the non-treatment. And now we are calibrating the key parameters in this decision tool. And the results are pretty promising now. And the next will, after we finalize the tour, we'll share to our stakeholders in New York State, and hopefully to get your comments and feedback and make the tour more useful and friendly. And we plan to publish this decision tour this year. And the second tool we are developing is the tool for adopting monetary-based strategies. And this tool, we are based on the economic analysis for organic blueberry in Oregon State. And so using this tool can provide information for our growers and whether you should adopt those monetary-based strategies and given your own farm characteristics. And now we are still calibrating the model setup and the parameters. And this year we'll plan to share this tour to our stakeholders in Oregon State and gather your feedback for this tour. And we would also keep working on the economic analysis for adopting food sampling in the farmers' operation. And we will extend the analysis to other states and other crops. So since last year, we have initiated the collaboration with our team in North Carolina, Michigan, and Maine. So we are working on a data collection and economic analysis. We'll be asking a similar question as we did for Oregon and New York State. What's the most profit maximizing SWD control strategy for your state and for your crop you're interested in? And also another new project or research idea we are interested in is the resistance. So we found significant resistance in California. And our team are interested in how this resistance would affect the SWD control, the also growers' decisions and your economic outcomes. And we are trying to help to respond to this development of resistance for your management controls and for SWD. And so we are specifically interested in to answer the question, how do the biological characteristics of pest and also growers' spray practices affect your pesticide resistance and consequently affect your welfare of growers. And next, we'll have Karina to present the plan for the grower survey.
A different idea we had is to evaluate growers' decision to adopt IPM-friendly practices related on spot wind Drosophila. This will consist on conducting surveys in key production states and focus on blueberries, since it is the most constant crop affected by SWD in various states. So the idea is to have different scenarios consistent of IPM-friendly practices, including expected efficacy of different practices in the short and the long term, and associated cost. And then also something that is very intriguing is what is the effect of neighborhood practices on the decision to adopt different control strategies. That is all what we have. We can pass to objective 3.
Hi, Ash.
Yep, Ash stepped away for a second, but we will be getting objective 3 up. Did you want any feedback on objective 2 at this point?
Yes, of course, if our stakeholders have any comments or the questions about objective 2, we would love to hear that now. If not, we can move to the objective 3 and we can having growers comments later after the webinar.
It's always the fun moment of feedback chicken. Who will be the first to provide a comment? Or Shin King, if you want to put up your presentation, because I believe
Yeah,
you need to share your own.
Okay, thank you, Joe. Can I show my screen?
I believe you have that capability.
Okay. Okay, I just show my screen. Can you see it?
We can.
Or you cannot?
We can. We
Oh,
can
okay,
see.
okay.
We
Okay,
see your
great.
slides and now we see just the presentation.
Okay, thank you. Oh, hi everyone. So I'm going to discuss, the ongoing studies and future plans for the biocontrol section. And we all heard yesterday, we got 2 most wanted pesticides, the Glassbus presennis, I just call GB, and the Banana japonico, let's just call AOJ for easy. And so far we have at least 11 members from this SCRI team involved in this nearly nationwide effort. And so I know there are a lot of study going on, student postdoc working on different areas. And I thought, maybe I don't want to talk more specific. Actually, I don't know specific study everybody doing. But instead, I'm going to sort of like propose, the major areas I think we should be focused on and moving forward, and maybe also continue and cover some study we're already going on, we're already working on, and so just continue. And so let me just talk in general, for the 4 areas that I think we should be focusing in the near future. The first, of course, the most important is the release and the monitoring of the establishment of and the impact of the 2 key pesticides. I think the GB has so far been released in 15 states as shows this map. So our guys want to expand this map. And I know the SI funding is ending This is last year, but luckily, you know, I think we also get some other support from other grant like the OIEA grant. This is also a nationwide project, I think, leading by Phil Fanning and Jenna Lee. And another member of this SI team involved in this grant also. And like some regional grant, like the CPPM, I think involved Maine and New York, New Jersey, you know, and I think Phil, Greg, and Sarah, you know, they're working on this. And the area-wide project involved Oregon, Washington, and California. And this is probably led by Jenna Lee. And also this year, we got a little bit of fund bill funding to support this in Delaware, Maryland, and Pennsylvania, because some states in Maryland, they don't have funding to do this. And I'm located in Delaware. I have ring of my SCRI funding, and so it's great that we get some funding to continue this effort. And also there are a lot of state support. So I think there's no promise, and hopefully, you know, we can continue this effort. And as Ken mentioned yesterday, you know, for the success of any by-control project, it nearly takes several years effort. So hopefully we can continue to get some support from, you know, if this SCRI funding is ending and continue for the next few years. One of the big challenges for the least larger number of this pesticide is, you know, the rearing. And I know, you know, there's some states still, some neighbors still have some difficulty, you know, during the contamination of their colony. But also some states doing very well, like I think Oregon, California, Michigan, New Jersey, Delaware, you know, we're doing okay. And I heard the New Jersey Department of Agriculture, they're actually doing very well in this wasp, and CSI has already indicated, you know, they're going to increase the number of sites this year for the lease in New Jersey. And so this is great. And I think we'll discuss how to improve the learning methods, and there's going to be a SW by-control symposium for the next ESA meeting, and we are going to cover this topic. And also, you heard yesterday, Ken's talking about the cold storage, you know, and I think he's continuing working on this. I think this also will be very helpful to help us to build a larger number for scheduled release, you know, in more size. So I think moving forward, this will be continued nationwide effort, and this is the most important plan for the coming year and maybe hopefully for the next few years. So this is one area I want to talk. The second area, you know, this is nearly a big puzzle. We are doing, you know, we're doing lot of different experiments, try to understand better of what kind of ecological factors will affect the efficiency and the establishment of these two key pesticides. And I draw this, you know, picture. You can see, you know, there are a lot of different layers of factors interacting. This will automatically, you know, affect the outcome of this project. And for example, from the large scale environment, the climatic tolerance will certainly affect or maybe determine the geographic distribution of the two pesticides. And also there's some landscape effect, you know, maybe also interacting with some other natural enemies. So yeah, so several labs are already working on this field. I think it's leading some study on the overwintering survival. And Ken's lab previously have done some dipole temperature studies. And let me just move quickly on this, just now I'll go back. Now, this is typically the life cycle of this pesticide. Most of those novel pesticides of Drosophila are very similar. So typically the endodipoles in fall when temperature dropped, dipoles as larvae in the host pupillament, and then they wake up in next spring when temperature rising up, but then they emerging in later spring or early summer, depending on the location. And so nearly there's a very, very short window, probably from May, June to September, October. And so this is very important for us to understanding what is the mechanism inducing the dipoles and terminate the dipoles. And we still need a lot of work to be done on this to fully understanding the mechanism, I think. So this is the projected distribution of GB, and I'm still working on this. This is based on the non-native distribution of GB in East Asia, and then based on the matchup of weather condition from the wasp native range was North American. So we project this the potential distribution in North America. And this bar on the left, you see this is the suitability index. So green is not color, it means very suitable, and zeta blue color means not suitable. But based on this projection, you can see a larger area along the East Coast and the Midwest, and also Pacific Northwest. It seems suitable for this pestoid. You know, in some area like very hot, dry, like Southern California, Southern Florida, and maybe in Canada, maybe it's too hot, too cold, or too dry. Maybe it's not suitable for this pestoid. Yeah, so I go back to this photo, this slide. So we already working on some of this, areas, try to understanding better to predict the, the distribution. And then the second layer is about a host fruit effect. As we know the SWD has such wide range of hosts, and then I can talk about yesterday, the issue result from Michigan. That's why you can see, the number of wasps from different fruits are quite different. And certainly the phenology, the availability, and host fruit species size were all play into and this effect on the efficiency and the population dynamics. So a lot of stuff needs to be done to further understanding. And I think we already started, I think here in Delaware, we are working on the host fruit effect. And I see that I think he's working on the multiple chart-top interaction, look at how the wasp responds to the chemical cues from host and host fruit. And also we need to look at the potential effect, the other close related host. We know like those species can develop from monogaster, and which is the most abundant host in the field. So that might be good, maybe help the wasp to build a high population, particularly for the winter time. But it might be directly, indirectly interacting with the species through the alternative host. So this is more needs to be done on this area. And also I think that from pestoids itself, we need to understand better their foraging behavior and how interacting with the other pestoids. And then finally, I think we need to develop methods how to assess the impact of key pestoids. So this is the area I just missed. I think we are more or less, we already started working on that, and because so many labs working on this, so I probably missing some study everybody working on, and we can discuss and you can add on. The solar area, I think this is something Ken and I have been considering, it's about how to explore the genetic source. The genetic diversity species we know so far is very, very, very low, because this is the least species, the glass species crack only from one location, one time, and this is indicating the yellow star is in Tokyo, Japan. And if you look at this map, this is the non-range of the two pestoids in East Asia. That's just based on where we surveyed. We actually don't know exactly range because it's impossible to survey everywhere. But you can see, they are widely distributed in East Asia. For example, this red dot is the GB. You can find them, as far as in Beijing and in China and in Southwest in that area. And the LB even have wider range than the GB. And in all different areas, both species are found together. And so it's possible, what if, the GB is not able to establish in a certain area? I think it's possible you could, introduce the population from different locations they might be different, in some key ecological traits, particularly, the cold or heat tolerance. And so they might be adapted well to different climatic zones than the one we already had. And so I think the idea is to try to build, the climatic resilient biocontrol system. That's easy to say, but nearly hard to do. And the last few years, because of COVID, we were able to do anything. And I think King is thinking about to go back to East Asia this summer to collect fresh specimen. So yeah, this is the area I think we should explore. The last area is how we integrating this available biocontrol tools into the ecologically based IPM strategies. I think we're already working on this. Ash lab working on some non-target impact of he's screening a wide range of pesticides, the non-target impact on those major pesticides. And Cesar, I think he's leading, coordinating a study to assess the compatibility of the two major pesticides with the combi protected and also the other pesticides, EPNs and so this is really very helpful, to understanding how to increase the impact of this pesticides by using reduced risk-reduced pesticides. And also, I heard some state working on some other nature enemies, such as the nematodes. I think Michigan State, California, Florida. I think some lab are working on this. So eventually, I want just to put this. This is the graph when we wrote the review paper a few years ago. This is taught about the framework and how to integrate all available biocontrol tools into IPM strategies. And so now, for example, the classical biocontrol, if the release of GB and the established population of AOG nearly can be effective, we might not need to think about the other pesticides, But if that's not working or not working enough, we might think about augmentative release, even the pure pesticides. But I think whatever we're doing, we should always, protect those nature enemies by trying to using risk-reduced pesticides. And in the future, might be some other nature enemies like nematode can be also used. But this still, I think, a long way to go. I think the goal, is one to establish the major nature enemies, and hopefully they can bring down the population, the entire agricultural landscape. And that may be not able to control this pest completely, but we make other control methods more, effective economically. Yeah, so I do want to talk about this, and if I'm missing anything, and I saw Kim also here can add on. And so if I'm missing any experiment everybody was doing, can also please add on. Thank you. Ash.
So before we move on,
Hi.
one question that I had for this team is, with all the new releases of GB and our survey to see if there's establishment, will there be any training on identification of all of these parasitic wasps?
Yeah, actually, I'm not sure if you can hear me. I kind of lost. Can you hear me?
Yes.
Yes, so the training is already, we already had one, and I heard somebody talking about, I think Adam from Oregon, is thinking about to organizing another workshop. Yeah, I think quite a lot of neighbor now they're able to do to separate the two major pests of the GB and the AOG. And might be needed, for another training. And I think yeah, we have to go back to check with Adam. I think Adam Paul, they're talking about for next workshop. Okay.
I think Greg has another question.
Mhm.
Shinking, I think
Huh?
Greg has a question.
Yeah.
Okay.
You hear me?
Oh, yes, please, yeah.
No, this is kind of an aside a bit, but since we had Leptobalina show up, Japonica kind of on its own, and both Ganaspis and Leptobalina showed up in Canada and Washington on their own, are you or other people kind of thinking about other species that might kind of get here? I've been thinking about that Asabora species that it seemed to be very effective, but a big generalist. And I wonder if we should be, at least as we're looking through these other, looking through our collections, we should be thinking about, how would we identify these other species?
Yeah, that's a good question, Gary. So in Delaware, we actually collect other species, the Asabara diffusus. This also was found in British Columbia. I think maybe also in Washington. I have to check this. So there's some Asabara species, but the problem with Asabara also, this group is very, very hard to identify. And I've been talking with taxonomists who specialize on this, the Bob, I think, Bob Kula from the USDA lab. I sent him some specimen. He was saying, this is a very, very complex group, also very hard to identify. And we must have also the aid of molecular tools to identify them. Yeah, it's possible. I would encourage everybody to pay attention. Is any pestoids. The one we talk about from Asia is about Japonico. Yeah, this is one of the very generous species. We are very surprised why this one didn't show up. Instead, more specialized AOG show up. Yeah, but we don't know. I think you might have found, this the Sabara Japonico in Asia mainly attacks the other Drosophilus. Unless you may be sampling the other Drosophilus, you have more chance to find it. Yeah, I always just keep attention, pay attention to, whatever you collect that we should be look at.
Okay, thanks.
Kent also added a comment that we don't want Asabara japonica because it interferes with the other ones. So any other questions for the biocontrol?
I had a follow-up. So if we do find other parasitoids that they're not GB or LJ and we're not really sure, what would be the best way to store them until we could get identification?
Yeah. So identification now, I met Bethany from the USDA lab. He is specialized on the Phygitis, including the LJ, GB, and other Phygitis. And then I just mentioned Bob Acuna. He specialized on Baconidae, including the Asabara japonica. Yeah. So normally I would send the specimen for them for the ID. But you should also, store them in molecular grade alcohol, just in case they want to do some molecular identification as well. Yeah, if anybody, interesting, I can forward you, I think a document can show, the different morphology of this common pestoids. And actually, it's not difficult to separate the LJGB just based on some very, very distinct morphological characters.
Okay. So I'm next. So I'll be discussing the behavioral control part of the project. So I'm not going to be presenting data. I presented the data yesterday, but I want this to be more like a discussion on where to go from here. So as I mentioned yesterday, the group, our team has been working on developing novel behavior-based strategies to manage spotted wing and also evaluating the existing ones. So with the hopes of reducing insecticide applications. So that's kind of the ultimate goal for us, is to see whether we can implement behavioral control to manipulate spotted wing Drosophila behavior, so we can reduce the amount of insecticide that we apply. So the plans that we have for this year, we are transitioning now towards looking at how we can integrate different strategies. And one of the things that we want to know is whether we can, if behavioral control would be complementary with biological control. So we're looking at what are the non-target effects of insecticides when mixed with some of these strategies and on the parasitoids that Shinkin described. So that's where our efforts are going towards, looking at these non-target effects. So as was mentioned, there's 2 parasitoids that are either being released in the case of Canaspis brasiliensis, or looks like are established in many states, like Leptopolina japonica. And the idea of the experiments that we're planning to do this year is to test different conventional and organic insecticides mixed with the Combi Protect and also without the Combi Protect, to look at the effects on these parasitoids. So we're going to be testing 2 application methods, the ones that I described yesterday. So one is the cover spray and the other one is the bait spray. For the bait spray, it is difficult to mimic what the bait spray will look like in the field. But the idea is like to just have droplets that we apply on a Petri dish and look at different numbers of these droplets in the Petri dish. So looking at density of droplets and how that is affecting the chances of the parasitoids finding these droplets and having contact with the droplets and dying from that. So there's several states that are interested in conducting these studies, including New Jersey, Georgia, Michigan, Maine, Oregon, Washington, Florida, and Minnesota. And other plans for these are from Greg Loeb's group. They are looking into doing more studies with the 2-pentyl furan. As I mentioned, this is a repellent that they are testing for spotted wing Drosophila. They want to look at how the physiological state of the fly and the sex of the fly affects their response. So they're going to be conducting some gated trap assays and also some Petri dish assays where they are going to observe the flies, the different sexes, and also the different physiological states or status. They are also going to look at how, similar to what I mentioned with the insecticides and the Combi Protect, they are going to also look at how the parasitoids, the spotted wing Drosophila parasitoids, are responding to the 2PF, to these repellents. So they are going to be conducting some olfactometer, white tube assays with the parasitoids to look at their response. So these are kind of future current plans for us to kind of finish up with this project and especially this sub objective. So we are planning to publish papers. We have already about at least 2 years of data that we have collected on Combi Protect. These have been data that I showed some, I showed it just part of this data that we have been collecting yesterday. So these data are from lab semi-field studies that were conducted in different states. Also, Greg has some data on 2PF with different deployment methods. As I mentioned, they have been looking at different ways to deploy the 2PF using the puffers, and yesterday I showed you those spirals. They have also used in the past like sachets. Those are the ones that we have been employing currently. And also they are looking at the additive effects of 2PF with other repellents. There's also like plans to conduct field trials this year with the Combi Protect. Also doing the combining 2PF with other potential contact repellents. This is work that Greg is planning to do. And also we'll be testing some new repellents. I know that Greg is also testing, with the 2PF combinations of repellents with attractants to develop push-pull systems. As far as lab studies, we'll be conducting behavioral assessments to understand the mechanism on Spotted Drosophila. One of the things that we want to learn more is how these repellents work. The mechanism, whether it's a long range, short range effect, and also the effect of behavioral control strategies, as I mentioned, on parasitoids. So we're going to start with looking at Combi Protect in combination with different insecticides on these parasitoids. So where are they now? I'm sure like a lot of you are asking, like, when are these strategies going to be available, become available? So some of them are to some extent, but most of them are not yet. So ACTRA, that's something that I discussed in the past in previous meetings. That's something that we tested for many years. It's an attract and kill formulation that has is a waxy a substrate that you can apply mechanically in different ways. It has a slow release. It releases slowly semiochemicals, and you can mix it with an insecticide. So the company has this matrix that you can just mix it with any insecticide that you want, and you can spray it in your field. The problem that, and I was communicating with Agenor this morning. He's in Africa right now. I was hoping that he could join us to give us an update. We have been in discussions with EPA in the past couple of years because the company is having a hard time registering the product because it contains several attractive components, and each component needs to be registered separately, and they are treated as biopesticides. So as you can imagine, that adds a lot of the cost to the company. So they are trying to work with EPA to see how they can make the process of registering these semiochemicals faster and not have to pay such a high price. So that's where we are with that. We are still in conversations with EPA. Hopefully that will improve in the future. So decoy, that's something that Vaughn developed. I believe that they are already, and there were some comments made by the stakeholders that they are happy on the performance of this technology. It has limited registration in some of the states, so it's available to some growers, but it's not available nationwide at this point. And I don't know if Vaughn wants to give an update, or I know Jimmy is very familiar with it because they have been using, Triskel's has been using the decoy. Combi Protect is the one that I have been working with. We have been working with lately. That's the one that I show you the data, as I mentioned. This product is available in Europe, and the company is introducing it in the US. Sarah Risotto, actually, like, also I was in communication with her because in preparation for this call, because I wanted to get an update from these companies on where the product is at. And she mentioned that there is registration. The company needs to register the product state by state because different states have different regulations on how these products are registered. So she has to work. Some states are easy, some of them are not that easy. So the company is going with the easy ones. And I believe like Oregon and New Jersey are easy ones. And so they are right now they are working on a label. They don't have a label. She's told me that they have a draft of a label, but that's going to be finalized hopefully soon. So once that's available, then the states that don't require registration can use the product. As far as repellents, that's kind of a little bit far from being implemented at this point. As I mentioned, there's a lot of challenges of using repellents in agroecosystems, that just in general, because of the volatility, how they are deployed, the amount that is needed to actually repel an insect. It's more difficult to implement a repellent than an attractant. And as I mentioned yesterday, it's better like if we combine multiple strategies instead of just using one. So maybe repellents by themselves might not work as well as when we use them in combination with attractants in push-pull systems. But we still lack sufficient data to use any of these repellents at this point. Most of the work that we have done so far, and I showed also like the work that Greg is doing is mainly in small plots where we put a lot of the repellent in these plots. So they work at that level, but in larger scales, we don't know whether that's going to be feasible, cost-effective, efficient. So we need more work on that. So these are kind of my questions to kind of end, and I'll welcome any input from you. But the big question that I have is that, at the end is how can we best integrate behavioral control with our existing management strategies? I don't, from all the years that I have been working with these strategies, they work, but they don't provide 100% control. So you need to integrate them with other methods. You have to have something that suppresses the population size. And then you can use this behavioral control. If you have high pressure, they tend to break down. So it needs to be integrated into existing management practices. So you might alternate some of these strategies with your chemical control, so you can reduce that way the amount of applications that you have during the season. So those things that we need to work out, how they can be integrated, and are they cost effective? Like a grower at the end, it's going to use whatever is most economical and effective. So we need to think about how much is going to cost. What are the additional costs of implementing these strategies to a grower, and kind of minimize, how can we minimize those costs? So I think that's all I have. I see there's a lot of things going on in the chat. I don't know if they're for me or. So any questions?
No, your question about integrating, I thought was interesting, because it seems like growers are very focused on protecting the ripe fruit when those develop, but we have this whole period earlier in the season when SWD is active, but we may not need, or it may not be worth spending the money on sprays. So I'm wondering what you think about the behavioral controls going early in the season to kind of mop things up when the population level is lower. And not expecting that to do the whole season work, but maybe, putting you in a better place for once you do have ripe fruit and need to protect those.
That's exactly, Rufus, what I was thinking, because that's where I think is the best timing for utilizing these strategies, kind of like using them to delay those applications. If we can work with biocontrol and also behavioral control, to delay those first applications, so the grower has, when the populations are still at a low density, I think that's when these strategies are going to work the best. I think when the populations are in, in August, when they are high, I think they are going to break down. This is going to be harder, and that's what our data shows. If you, I show yesterday with the Combi Protect, once the grower stopped spraying after the 4th week when we were doing our field study, the population increased of spotted wing, and that's when we started to see that the Combi Protect with at the half rate starts to not be as effective. If you keep the population low, I think that's where, that's when it's going to work the best. And I think if you alternate also, if you have, if you start with some kind of behavioral control, then, you try to apply, maybe rotate with another insecticide, the chemical control the next week, that keeps the population continue to the population down. Then you can do your, maybe again the behavioral control. So that's something that also like it would not be nice like to with Miguel and his group like to see, you know, how economical it would be like to make one application of something like Combi Protect or multiple applications, and when would be ideal to make those applications. Also, there was conversations about using them as a bait. I know Uwe is on the call. He made a comment that that's how they are using it in Europe. We have limited data, only the data that Vaughn is collecting from Oregon, showing that it does work. So that also is going to reduce the cost. So.
Yeah, thanks for those comments. That was very helpful.
Hey, Cesar, this is Ash speaking. Can you hear me?
I can hear you, but not very clear.
Sorry, I'm in a suboptimal connection situation. I'll be back to normal in a few minutes. But question is, are these strategies like Combi Protect, these set up attract and kill type approaches, how friendly are these with the biocontrol agents that we have? Do we have enough information to say something about it, or do we need to do some more research to make sure we know that aspect better, or what is the status?
So there's two things, you know, to address like on that subject. First, we're not releasing the parasitoids in our fields. So we're hoping that by doing that, we're minimizing their exposure to pesticides. So we're releasing them in, you know, in the non-crop habitats surrounding our fields. So that by itself, you know, I feel like that's going to help build the populations of the parasitoids and provide the control that we hope outside outside the fields. There is, however, you know, like they can fly, so there's the possibility that they will move to our fields. So that's where, you know, we're looking at, you know, see which insecticides might be more, which strategies and with what insecticides there might be more compatible with the parasitoids. So again, you know, like I feel like our intent is not to expose the parasitoids to these chemicals, but in case they are exposed, you know, we want to see whether they are compatible. These strategies can be compatible. The numbers I would expect of a spotted wing, which we see, you know, from data, is that is usually higher outside our fields than in the field. So we hope that there's not much incentive for the parasitoids to move into the fields because there's not much spotted wing, but there's a lot of fruit. So that's why, you know, I'm interested on what cues they are using to find the spotted wing. Shinking mentioned that that's something that my student is going to be looking at because that might help us, like, you know, are they going to move into our fields? What are the chances that they will do that? How can we conserve them better, if so?
Thank you, appreciate it.
Any other? Is there any on the chat? Cesar, we're excited about the. Are there any plants that could produce repelling compounds to spotted wing Drosophila? Huh. I think there was a study in Europe that was looking into that, like a trap fruit or some trap plant for a spotted wing. And they were finding that it was working somewhat, but I believe that it wasn't very good. That's what I remember. I remember, I think it was presented at, I don't know if anybody remember this, because I think it was presented in the International Congress of Entomology. I found it interesting, the concept, but they did not find that it was working that well. Like they did find some plants that were not good for a spotted wing, but I don't know that I just like, it's such a prolific pest that I don't know if, but yeah, I don't know. That's a good, so far we have been working with just synthetic compounds. There's things that they don't like, that we know that they don't like. My work and also Greg's lab from Dawn's work shows that they don't like the smell of fruit that is infected by fungi. So these fungal compounds, most likely, like the fungus is causing the fruit to change the volatiles emissions, which is what we find. And spotted wing Drosophila doesn't like it. Of course, they are competing, for resources. So they don't, the larvae don't perform well when the fruit is infected with these fungal pathogens. So they avoid them. So there's some sources that we can look and try to discover new repellents. But yeah.
Cesar, has your group or Greg's group made any attempts to identify what compound may be associated with those fungi that are repellent to SWD?
Yeah, we identified 2 compounds that we published that paper like at the end of last year. So this I'll share the paper so you can look it up. And I had a master's student working on that, and I was collaborating with Caitlin Raring from the USDA lab in Florida, who studies these fungal volatiles from microbes.
Ash and Cesar, for the botrytis work, we identified some things that seem to be different coming off of the botrytis compared to a fruit without it. And Dong is still working on doing some GCEAD work and trying to identify the compounds. I don't think it's going to be simple chemistry in this case, or at least we don't know that one way or the other. And we're not sure which of these compounds that are different are biologically active yet. So we're not quite as far along as what Cesar's done with anthracnose. But I think it's interesting to pursue, because at least tentatively, I would say that the repellent effect of the compounds from botrytis are acting at a lower concentration than things like 2PF. And it's one of the problems with 2PF that it seems to really only work at pretty high concentrations, and it's very expensive to be able to generate that kind of level of concentration, especially under realistic field conditions. So, I mean, and that's a challenge for all these more volatile repellents. And one of the reasons we got more interested in contact repellents, or combining contact repellents with spatial repellents to get more efficacy, maybe reduce the cost down if the contact repellents have better residual.
Yeah, and that's your compound is less volatile than the compounds that we identified. So so ours are more volatile. So I don't know, so far we haven't tested in larger field conditions. You have, so I don't know how it compares with 2PF.
Okay.
So we're going to do more studies this summer with the larger cages to see how it works, it performs. But yeah, it's challenging with the repellents.
Yeah, and 2PF is particularly problem of this expensive. It's not just that you need high concentrations, but it's pretty damn expensive right now to produce. If someone can make a breakthrough and figure out how to kind of synthesize it in a cheap way, maybe it'd have a little more cost favorables in terms of cost. But right now it's a pretty expensive compound. That's one of the reasons we're looking at some alternatives that seem to act similar to 2PF, but maybe a little cheaper. We'll see.
There's a question on this is something that I haven't tested, but there was a comments yesterday on whether you can control spotted wing Drosophila in the soil by treating the soil instead of treating the bush. So can we apply these strategies to the soil? That's something that I haven't tested, but I know Vaughn has done some testing. Greg, have you done? Yeah, I think you also commented yesterday about that.
We haven't. What we've been looking at is applying insecticides, actual, synthetic insecticides on the ground below the canopy where there might be some fruit dropping down and stuff. And we have seen under clean harvesting, where you're not allowing sort of an excess of fruit in the planting, that we've seen under field conditions, the insecticides effective down there at reducing infestation in the canopy. I don't know exactly how it's working, but I have hypothesized that it's not primarily doing it by killing, let's say, large larvae as they drop to the ground, but adults are moving to the ground or near the ground and getting exposed to these insecticides. And that's kind of what I was thinking about when I was thinking about, well, can we put the attract and kill kind of a little bit lower below the fruit zone? If these flies are already going down there, maybe, and the microenvironment might be a little more favorable at times of the year, et cetera, that might be a way to target them without having to spray the crop. That was kind of my thinking on it.
Yeah, but there was a comment that Uwe made yesterday saying that for the Combi Protect, you shouldn't apply it. He said to the soil because it needs to be in contact with the leaf.
Mm-hmm.
But I don't know, like for Actra that has, an attractant, it could work. We did apply it in the bark and the leaf, and we saw similar effects, but we never applied it in the soil.
Well, the gum is sometimes placed on the ground, isn't it?
Yeah,
And
it's outside.
flies are willing to go down there for that.
Yeah, like I think the food grade gum is like, it's just placed kind of like in between plants or
And near
yeah,
irrigation lines, if you can keep
irrigation lines. Yeah. Anything else? Yeah, Jimmy said that Iska says also Actra needs to touch the leaf. It might be more like because it adheres to the leaf better because it's kind of like a waxy, it dries, it needs to dry in a substrate. I don't know, like if it's in the soil, I don't know, buried in the soil, I don't know. My feeling is like there's going to be like, I having also been thinking, I don't know if I have more time for this, but I have been thinking what's next, for all of us, what's the next step? Like, because, our grant is ending. What do we want to do from here? Like, where where should we go? And I feel like there's going to be more products coming up, you know, like as we heard, like in the last 2 days, like there was products that I never heard of, like biomagnet, ruby, now the Drosom Mois. I'm sure like the companies are going to come up with new products that kind of like do similar things, and which is good to me, because that's something that, you know, growers are going to have more availability of different different products that they can use, and you know, that hopefully we can test. But again, you know, integrating, like that's why I had that slide on at the end of to me, like, it's how can we integrate this to reduce insecticide use? You know, how at the end is going to be the cost, at the end is going to be how, you know, when the timing, the frequency that we use them.
Cesar, do you have any updates on ATRA's registration? What was it?
No, I was going to ask, that's why I wanted Agenor to join us, but as I said, he's in Africa. He sent me nice pictures of a safari. I told him life is good. But no, he didn't mention this. If there was any change, I feel like I would have heard. So my feeling is like there has not been any progress. The last thing that happened in December was that the company was trying like to tell EPA if they could register a product as a blend instead of registering individual compounds separately to make it more cost effective, and EPA said no. So they did not allow them to register it, because the number of compounds in the blend is it goes depending on which ACTRA. Remember, like we had two ACTRAs, like one was the TD, the Thun-Decker, and then the other one was
OR1.
the OR.
TD was the more latest version or the updated version.
Exactly, but the TD has more components. So they were going to go with the OR, which we found, like Arun's data finds, that it's not as effective as TD. TD is more competitive, but it's because these are based on blend compounds. Like the more complex the blend, the better, the more specific they are, and the better they are at attracting Spotted Wing Drosophila. So so the TD has like 9 components, I believe, and it was better at competing against the fruit. But that means for the company means that they have to register 5 separate compounds and pay registration for 9 separate individual compounds. And the company was like, we're not doing this. So so they were going to go with the OR1 that was not as effective, but has less volatiles.
So they did not get the exemption like Combi Protect did.
No, because they Combi Protect and Uwe, you can correct me if I'm wrong. It's the same thing that I think they did with the decoy, is that they are releasing the active ingredients. ISCA does not want to release the active ingredients. They want to keep it, they want to keep the patent. So if you don't release the active ingredients, you have to like go through a whole process of tolerance.
You know, I was talking to Agenor, and it seems like they are selling overseas a lot of that.
Yeah, because they don't require the things that they require here. Yes. Yeah, they can sell in South America, Europe, some places in Europe. Yeah.
All right, perfect. So do we know anything, any new products on the sort of immediate horizon?
We were talking about the Sutera product, biomagnet ruby, but I actually shared that information with Agenor because they have an EPA approval, but it is an insert. So I need to see how it works because I don't think it's something that you can spray it. I think it's something that you might hang. I don't know how, but it's still like if it's for control purposes, they have to go through registration. So I don't know, the product did not say how the attractant was applied. And it didn't say what the attractant components were. So I don't know. I think you know, to me, a grower is going to adopt these strategies if they are easy for them to apply them, you know. So how convenient they are like to apply, it's going to play a big role. Like, for example, I was attracted to Combi Protect because you just mix it with your tank and you just spray it. The Actra is a little bit more complicated because it's like a waxy material that you can apply it mechanically, but you need some specialized equipment. So how is they are, you know, how easy they are going to be to be applied? I think it's also going to be and you know, is going to affect how they are going to be adopted.
Biomagnet is Sutera product that I think Jimmy says it'll be registered in May in California.
Oh, Jimmy. Yeah, you see, they hang the bags. 60 bags. Yeah, that's the impression that I got. I was right. So it's kind of like something that you hang. Yeah, that's what I shared yesterday, Greg. Yes, you found the same thing. Is that that's the EPA registration? Yes, but if you look at that is delta methrin, so it doesn't say anything about the attractant. So I think the attractant is separate. It's very confusing. So the attractant, I don't know how it got registered. Ash, you're muted.
Greg just shared a link.
Yeah,
EPA
that's the same
document.
link that I shared yesterday.
Yeah,
I also found that.
excellent.
Yeah. And also Jimmy contacted us with the company. We haven't heard yet. Oh, Lauren has a from Sutera. Oh, nice.
Do we have Lauren on the call here?
Yeah, if Lauren is on the call.
All right, Lauren, please tell us a little bit about the product. Michaela, can you unmute Lauren if she's on the call?
I'm not seeing a Lauren in the attendee list.
Jimmy, is Lauren on the call? Is Lauren Simpson? Can comment. Yeah, it doesn't seem like.
No, I was just saying that you know, someone could email her and she could.
Oh, I see.
I can't see the participants.
Yeah.
All right. So yes, Cesar, if you can get in touch with Lauren, just get some more information and share with the team, that'll be great. And we'll just stay on the lookout for any new products that become available, and we'll include those in the tests down the road.
One
Go ahead.
comment, like I don't know, Greg. One of the things that we found last year, we tested like a push-pull, and we found more of an effect of the push, but not the pull. And I feel like you know, the attractants, the way that we are like pulling might not be the best by using these traps. I don't think I
I agree 100%. We see the same thing in our earlier work with 1-octane 3-all. It kind of had the better effect than the attractant kill, and similar work here recently that, yeah, we're getting the push, but that we haven't found the ideal pull, or either we're not locating it, distributing it correctly, or it's not the right attractant compared to the fruit. Yeah, I think, but there's just a huge amount of room to kind of look at those kinds of questions to kind of try to optimize it. That's my response to your question, what next? I think we've been thinking a lot about combining approaches, attract and kill with whatever repellents we can get that are economical and give us some effects. I mean, I would say we've tested azadirachtin as a contact repellent, and it higher concentrations. We actually see some efficacy even under small scale field trials, but it's a little bit inconsistent. And for whatever reason, they don't allow a higher concentration on the actual product labels. And we think we need to go higher to get that effect. I don't know if people can start tasting the stuff if you get a little higher. I don't know why there's that limit, but I don't know. Probably I have to talk to the companies on that one.
I like, you know, your approach. I think, you know, but the thing is that you need to know the mechanism on how these repellents are working in order to combine them. So they are like doing different things. And we don't know much about the mechanisms. So,
Yep, agreed.
yeah.
All right, let's go for the last question. Do you have any last question from the attendees, team, everybody else? Last question, comment? Oh, there's a comment by Jimmy. It says, as a direct is $330 per acre at high label rate. Wow.
Wow.
Only Jimmy can
There's
afford it.
that. Yes. Yes, only Jimmy can afford it.
I think I still have the ability to unmute. Can you guys hear me?
Yeah.
I just wanted to make a comment on sterile insect technology, and I don't know if that fits in this objective, Cesar, but you know, we had a lot of success last year in our trials in the United Kingdom with a company called Big Sis, and they achieve the sterility through irradiation, and then they sex sort and release just the sterile males. So we did this in raspberries in the summer and fall, and got 60 to 80% drop in larvae inside the fruit. So really great results from that. And that's a company that has commercialized their product and is offering it as a service to release sterile males in the fields. So there's great potential there. And I know Jana's working on the gene edited flies from Agrigene, but that's another interesting avenue for research.
Jimmy, is that company providing sterile and males within the US or is overseas?
Right now, it's still just for the UK, but they're talking about expanding into other parts of Europe and perhaps eventually in the US, but I'm not sure.
Do you know what approach or protocol they use to sterile insects? Is it radiation based or is it molecular genetic based?
For big cis, it's irradiation.
I know a company from Israel approached us, a number of our team members, to do some setup with the sterile technique, but we did not have enough facility here, and there was lots of paperwork involved to even get that started. But I don't know if there are still any takers, and company may be able to sponsor part of it to get that started.
I think Ash, they wanted to sell us equipment, no? Like, I think they came also here. They wanted to actually have somebody, because they met with our department chair and they want to actually yeah, and it was very expensive.
Yeah, that you're right, Cesar. There is a company looking around to try to get their equipment out in university hands, and that's the model that they're looking at, is like, how can we get you to purchase or cost share this equipment? Jimmy, with the situations that those flies were being released in, were those open field, high tunnel, small field isolated? Like, what was the environment in which you were getting those results?
Yeah, this was in raspberries that we grow under tunnels. So it's polyhoop tunnels, open on the sides and the entrances and exits. And they would overnight those sterile flies from their lab to the field. And then these retired birders were just looking to help out, reduce pesticides, and would release these flies out in the field twice weekly. And they started about a month or two before fruiting. So it was still flowering, or in some cases even just before flowering. They started very early.
So that's the radiation based, and there is a company, I think it's a spin-off from Imperial College, that the folks are doing a genetic based sterilization or some genetic drive based mechanism. They had done some work with SWD initially and wanted to bring it into the US, but the legislator or regulatory hurdles basically slowed them down. And I haven't heard from them since. It's been a while. Betsy Beers, I guess, was the first one they contacted. Then we all brought them into one of our meetings as well. So Betsy, have you heard from them ever since?
No, Ash, I haven't.
So it means that they got scared by the regulatory hurdles they had to face to bring their materials into the US.
Well, or things move slowly. I think they had to, the first thing they had to do was get a base of operations in the US so it wouldn't be, they wouldn't have import problems. And then they had to reproduce their methodology sort of on site. So that was the last I remember, but we should probably follow up with them.
Yeah, I'll get in touch with them to see what their status is. That would be something that would be a next step, I guess, or something that we haven't worked on yet. And also there was some California-based company out west. I don't know if they were collaborating with some of the team members. I heard maybe Jana was the one that they were collaborating with, some small scale controlled set of trials to see if any of their techniques, genetic techniques, would work, but never heard any updates on them. I tried to actually reach out to them as well, but never got any response back. All right, we are at the top of the hour. It is time to move on to next objective, which is objective 4. And we'll get the update on the plans and protocols for the upcoming season from objective 4 team, co-led by Rufus Isaacs and Joanna Cho. I think Christine is going to present the protocols. Is that right, Rufus?
Yes, that's correct.
No, perfect, Christine.
So just as a refresher, our objective 4 is to assess and reduce the risk of insecticide resistance development. So just a reminder for what we talked about yesterday, we actually detected evidence of 3 different molecular mechanisms of insecticide resistance in the California populations of Drosophila suzuki. We detected penetration resistance, as well as metabolic resistance, and then a form of target site resistance in which you have a reduced amount of the target being expressed. And it seems like there is a pattern in terms of which mechanisms are associated with what type of insecticide that's used, which can kind of help facilitate the making of our molecular diagnostic. So our first goal for the upcoming year is, or this year, is to actually do a nationwide survey for resistance using the newly developed molecular diagnostic. So as I mentioned yesterday, we were actually able to utilize the diagnostic with populations from Georgia that have unknown resistance status. And then from that, we were able to detect high levels of these gene expression and then suggest to Ash and his team to actually do the dose response assays. And then they were able to find resistance in the populations. So if we're able to do this screen that's faster than doing a bioassay, as well as taking less flies to start with, we can actually see whether or not resistance is starting to creep up nationwide. And then we can start putting in measures to actually combat that resistance. So what we would ask is that if you guys are willing to send us populations from your states, and then we can actually test it molecularly here, and then we can give you the results. And then from there, we can decide whether or not a dose response assay is necessary.
Yeah, so I think I was going to be presenting this piece. Thanks, Christine, for the introduction and review of yesterday. And yeah, so our group, this is the last year of the project. Do think we're considering as a group that we want to try and follow up on the work we've done, where we did just the bioassay method across the project, and then now we compare this with the molecular methods that Christine's been working on, and the data from Georgia, I think, give us good confidence that this approach is a good way to go, because we're already seeing that the 2 methods can align. So I have there a list of the states that we think are willing to be part of this year. If you're part of this project and you see your state not on the list and you want to be, please just put something in the chat or email us. Or conversely, if you see your state represented there and you weren't planning to be part of it, let us know that too. But we'll be getting together a team meeting to really nail down the details. But we do have a protocol that's been circulated, and we're trying to get every state to have at least 1 untreated site and at least 2 commercial farm collections, which would have had an experience of pesticide application and selection. And then those flies would be tested in state with the discriminating concentrations of 2 insecticides that we know we have the mechanisms nailed down for now with the work from California. So that's the spinosad and cedocypermethrin. So we'll do the bioassays in each state, get our % mortality data like we did previously. And then we're thinking if there's some survival, it would be really good to get the dose response, because that will give us some level of response rather than just the resistant or susceptible screen. And then that data could be then compared to the data we'll get from Joanna's lab with the molecular screening like Christine's been working on. So that's the sort of overview of what we're thinking. And I think there's, a benefit now to having the two kinds of data sets that we didn't have previously. We can, first of all, validate the molecular method and get a good sense of how that works across the whole country in different agricultural settings, different regions. We have these two chemical classes that we now know there's some resistance for and have the screening for. So we'll see if we get the same kind of responses with those. We'll be validating this new method and being able to publish that with a nationwide screen. And then we may end up seeing some differences across the country, because so far I think we have data from Georgia and California, and there may be differences across all these different areas. So I see a bunch of chat going on, and that's great. People are volunteering, and we'll kind of go back through the chat, and I'll collect that while maybe Christine is presenting the next slides. Okay, back to you, Christine.
Okay, thank you, Rufus. So the additional goal that our lab has for the upcoming year is to actually investigate an additional molecular mechanism for resistance. So one thing that we noticed in our data set is that a particular pathway, the spliceosome, is actually upregulated in our resistant lines. So splicing or alternative splicing is a natural process by which regions are removed from a mature mRNA molecule. And this allows for different proteins of different functions to be made from a single gene. So this single gene can encode for different proteins that have different functions, indicated by the schematic here. So you can have a case in which the building blocks exons 1, 2, and 3, and 4 can actually all be present together. And then you can have another protein that doesn't have exon 2, and you only have 1, 3, and 4. So far what we've seen is that some of these different splicing isoforms are actually more prevalent in the susceptible lines, and then some are actually more prevalent in the resistant lines. So it's possible that there is a change in splicing that's actually contributing to the resistance. And there are many studies now looking at how alternative splicing is involved in cancer. And there are therapeutic ways of combating cancer. So we can utilize that same technology here in order to also kind of reduce the resistance that's popping up. So we can maybe implement several of our different strategies together in order for the insecticides to go back to being as efficient as they were in the past. So that's kind of what our group is looking at right now.
I think that's back to me, and I think we wanted to also let this group know, people that are on the call today, although a lot of this work from the Objective 4 has been very lab-based, we definitely are thinking about extension outputs and how we can help expand this information back out beyond the project. The first thing is a guide to resistance and SWD and monitoring, and this is something that we need to pull together to kind of compile what we've learned so far, and hopefully that can help with people considering how they're going to approach resistance management in their different cropping regions. Of course, as more data comes out from the bioassays, that will update us, and this might have to be more like a living document on our SWD website, project website, than something we print, because it just seems like a very fluid situation. And then the resisting testing protocol is more for the research community to help explain to people what we've learned about how to run these bioassays, some of the tips and tricks and pitfalls to avoid. And that's something that we are developing and have been refining pretty much through the last few years. And that's something that we'll post to the project website. But I did note the comment that Hannah just popped up there about getting that to IRAC as well, which is a great idea, because that will be an international audience who may find that information useful too. So I think that's what Christine and I had planned to present, and we got some time left for discussion. We just kind of ran through that fairly quickly. I think Frank was going to be on the call. I don't know if he was able to join us again. because there are implications of all of this work for resistance management, and it might be interesting to talk about, you know, what does this mean for making recommendations and for considering how to approach SWD management now that we've learned more about the resistance and the mechanisms underlying that. So yeah, I just wanted to open that up for discussion about this objective 4 resistance topic. And I see that Frank just popped into the chat that he's on the call.
Yeah,
whoever's in charge of that.
Just muted before. So
Okay, he's back. There he is.
wasn't able to pop in.
Hi, Frank. Thanks for joining us.
No problem. Happy to be here. Yeah, actually, you know, I am really excited about this because I think that there may be the opportunity not only to more easily identify resistance, but also the type of resistance that we have. Christine mentioned that, you know, we see metabolic resistance and we see penetration resistance, and there may be this other. It looks like there's this other type of resistance as well. And I think that we can use that. I was just writing Cesar a note. I think we can use that like for spinosad resistance, if there's penetration resistance as one of the mechanisms, then there's no reason why, you know, something like Combi Protect, Cesar, wouldn't work better, you know, wouldn't make spinosad work better. I think so I'm excited to try that. And I was just sending an email on that. So I think that, you know, the mechanism is important to know what mechanism is causing it, because we may be able to actually manage the insecticide better because of that. But I also think it might be possible that it's not just, do we have a resistant population or not? It's how resistant is that population? And like in California, our resistance is at pretty high level. And so our options are probably a little less than it would be in places where you're just starting to detect the resistance. And so if we can, as part of the study this summer, be able to get sites where we're just starting to see some reduction in the susceptibility, but get dose responses with that, we may be able to, and that is a lot of work. So I'm not sure, you know, everybody can be doing that, but at least if in some of the states that have less resistant populations, if they can do dose responses along with that, we may be able to calibrate that molecular tool for it. And if we can do that, then, you know, this whole concept of resistance management, you could really do something about. And so I am really, you know, excited about this. And I'm really interested in seeing how this national survey happens if we can detect resistance at low levels in some places that we're not able to do right now. So that was kind of a long thing. I just wanted to say I am really excited about what Christine's doing. And, you know, we're happy to be working with Rufus on this national survey.
So Frank, one thing that came up, I mean, Christine's presentation yesterday got me thinking about a lot of potential ways we might adapt our spray programs. And with the penetration resistance, I was wondering if any of the adjuvants that are in the ag market, you know, is that a way to increase penetration into insects that are becoming resistant that way, or would they also be resistant to the penetrant type adjuvant materials?
Yeah, you know, we really haven't looked at that, Rufus. I mean, that's a whole another way that we've considered. We were looking at synergists, as she mentioned, but you know, adjuvants that might increase the penetration could also be useful. Now, the thing is, I'm not familiar with a lot of the formulations that already exist. So some of those formulations may already have some of the adjuvants in it that would increase penetration, you know, cucumber penetration. And so maybe with some insecticides that don't do that, it might be more helpful than with others. And that would be, you know, nice if we could talk to some of the manufacturers and see what if their formulations include that or not before we just start screening things.
Right. Yeah. So I did want to say I went back to the chat and I saw the comments about Montana and North Carolina. So we'll follow up about that. Great to have you aboard. there's a way we can make that happen.
Rufus, you mentioned adjuvants. Did you also include the phagostimulants in particular? I don't know if there is a room for them to, if penetration is an issue, that may be another way to improve ingestion.
Yeah, I think the phagostimulant might help for if it's penetration resistance primarily, like with the spinosad. And that's what I wanted to kind of propose to Cesar here, how he felt about that. And maybe we could design some sort of a study here to see if you know, with the hypothesis being that at least for penetration resistance with spinosad, will we get better mechanism, will we get better results than when metabolic resistance is the mechanism. And we, as Christine said, we've had populations that have primarily metabolic resistance and other ones that are a mixture. And Ash, you may have this type of situation already in Georgia, and that may be a really good opportunity to test Combi Protect on a population that we know has primarily, or at least a good part of it being penetration resistance, because, you know, I mean, in concept, it should work better when they're ingesting it then.
I think Frank, your group at UC Davis now having these characterized lines where you know the mechanism that they're resistant by, you know, a lot of these questions can now be addressed in a lab setting as a proof of concept to see can these adjustments work before we even have to think about taking it to the field to see if it helps with control.
Yeah.
So that's really
that's
valuable.
what I'm thinking too. Exactly, Rufus, and yeah, I mean, that's exactly what I'm thinking too, is that we can actually test that, but it would, and the other exciting thing, like Christine mentioned yesterday, is, you know, we did the work initially with these selected lines. And so do you see the same way of testing this molecular assay with native wild populations? Well, we did. You know, so that was really a exciting for me. And I think now that we've seen the same results from Georgia with ash, that we've been able to detect a population that's spinosad resistant just using the molecular assay. You know, I think it's really promising. And so these same questions with Combi Protect and everything, as long as we have populations that we know what the mechanism is, we could test that. And I think, you know, that's why this might be possible, Ash, with the flies from Georgia too. And we need to talk more about this. I mean, a lot of the results here are very recent, and so we haven't really had a chance to talk about potential study, but I think we could do that.
I had a question for Christine. How close or far are we from developing genetic markers that we can use just like we do our diagnostic dose, for example, for bioassays? With these methods, now that you know there are some mutations or overexpression or things like those, can we use those changes to develop genetic markers or molecular markers?
Yeah, so we actually think that the 5 genes that we're testing now actually are pretty robust molecular markers for testing whether or not there's resistance. So we have 2 of the cuticular genes and 3 of the metabolic genes that cover different classes of cytochrome P450s. And it seems to be pretty consistent, as well as being able to detect lower levels of resistance. So we think we can actually use those 5 as the actual biomarkers.
That would be really cool if we can do that.
That's why I'm excited about it, Ash, and why I'd really like to get some more dose response data along with it this summer from other places too. Because, you know, it takes a long time to do the dose responses and a lot of flies.
Oh yeah, and another thing is with these bioassays, no matter what we do, there's always a element of doubt in it. You know,
Yeah.
maybe something else was variation. There was some other reason for this, what we saw. But when it comes to those genetic changes, that's set up a confirmation right there.
Yep.
Any more questions around this issue? That was good discussion, and yeah, we'll be following up with everybody that's interested in working on this project after today's meeting.
So the action items, Rufus, for your objective 4 are to do a subgroup meeting or objective meeting,
Yep.
to finalize the protocols, do a national survey this year, and then if anything, any issues are detected in those initial bioassays, then refer the samples to Joanna's lab for more genetic analysis.
Yeah, and we've got some details in the protocol of, you know, how to send the flies and the best way to do that. So that's all in there. And then I did notice Jimmy just put a question in the chat about industry sending in samples. I mean, I think we have our usual time and budget constraints on this at the moment. So I think if you're in a particular area, Jimmy, connect up with the, you know, the university land grant folks that are in that area would be the best approach. I think they're making, you know, they're making decisions about where they have the resources to be able to get the flies. Maybe they can fit some in, but I can't speak for them, and I know we're constrained on how many we can run.
Yeah, I'd say, you know, at this point, this really isn't a commercial application, but I think we're getting there. And so there's just a limited number of samples that we can process, but I think we can process a lot more because the molecular technique doesn't require us to have so many flies to do like you would need to do even with the discriminating dose assay, but particularly with a dose response assay. And so, you know, we might, you know, we can talk about what we can handle from collaborators. We've talked about that around the country, and Joanna's lab felt like with a lot of the other labs involved with the project here that might be able to get 10 sites per state even as a possibility and process that. But that's not like, you know, doing every field from a lot of different places. So hopefully this is something that can be, you know, used by some labs or something that can do this commercially for people, or even I saw Jimmy mention this on here. Maybe it's something that Driscoll's can actually do in-house. You know, if we really validate it. You might comment on that, Christine, how difficult it might be for somebody. What would it take for a lab potentially to be able to test this the way you do?
I could usually do within a day, realistically, I could probably test about maybe like 5 colonies at a time. Because I do biological replicates within each test. I could probably do 5 colonies at a time, but I don't know, you know, how much more in terms of like being able to do it every day kind of thing. So I would have to talk to Joanna about that to come up with a plan that would be feasible. We could also talk to different facilities on campus and see whether they're willing to run the qPCR assays if I just provide the samples to them, like the RNA samples, and then they could just do the qPCR, and maybe we can outsource that part of it.
Christine, I wasn't proposing that. I guess I was trying to temper
I'm sorry.
enthusiasm about doing this commercially. I mean, doing a bunch of commercial samples too, because we're still in this validation. But my question more was, if you were going to transfer this technology to a you know, a private lab, what types of equipment would they need, and about how many flies at a time to test so that they would have a good idea of what it might, if it would be feasible to do commercially or not.
Oh, I see. Okay. I think it is very feasible at the commercial level. In terms of equipment, they would just need an incubator for the flies, and then a cold centrifuge and a qPCR machine. So that would be like the big expense purchases. And then depending on how big of a qPCR machine they have, that would dictate how many samples can be run at a time. But each of those plates only take an hour and a half. So I think at the commercial level, you could probably do like, you know, a big range of a big number of samples. So I think it would work at the commercial scale.
Thanks, Christine. Yeah. So Jimmy, to answer your question, I think it's something that could, I've kind of discussed this a little bit with them already. And I think that, you know, a lab could get set up to do this sort of thing and potentially do a lot of samples. But I think that I still feel like we need to validate this on a wider scale and see what information we can actually get out of the, you know, if we can get the levels of resistance and all that worked out so we could document the value. But I think if we had that, it could be done. And because, you know, it's not, I mean, it's, to me, it's really difficult to do it, but for Christine and Joanna, it's like not rocket science for them. And it's, and they can handle quite a few samples, but I think at this year, we're just not prepared to be handling a lot of samples from commercial sites yet. And we certainly don't want to do that long term.
I've been thinking about the commercialization aspect too here, and we're, you know, maybe we won't have the same demand if we don't have as much resistance expression. But for example, we have a state diagnostics lab that does insect ID, disease ID, nematodes, but they also have a molecular unit. Mm-hmm. And if the technology was available and they knew the protocols and had the right materials, I'm sure they could offer that as a service, or it would go to someone like AgDia or one of those like commercial concerns where they provide that service for a fee and people could send insects there, and they usually have a pretty quick turnaround. You know, it's within a week you'd know, and then you could, that timeline would be enough to
I think you were asking about, like, could you do something similar to what they do with COVID or did with COVID or virus samples and things? And, you know, we have virus labs in California already that do a lot of ag things with screening for different types of viruses and plant materials and things that just, you know, people do before they plant the plants, and they're commercial labs. And exactly those types of people already have the equipment. And I think they could even test that sort of thing. It's not like it wouldn't be beyond their abilities for sure.
Yeah, so that's where we hope this is going. But yeah, I agree with Frank. For this year, we're trying to keep it tight and more of a research validation process, so that we've got confidence for that next step. Know what it can and can't do.
Yeah, and people that know me know that I wouldn't be all excited about something if I didn't think it could be used commercially at some point. And honestly, I think this has got a possibility. So.
Joe or Kayla mentioned in the comments that they know somebody at some lab who might be interested.
Yeah, as Frank was saying, there are a number of labs that if the method's made available, we can let them know that this is something that people are interested in. So I think it was either Frank or Rufus said it. So.
Mm-hmm. And as you mentioned, Rufus, developing some kind of a document for outreach purposes for just resistance management and all that. It should be a kind of a fluid document because eventually we may be able to include information like this in it too. Just make it available and, you know, encourage private labs to be doing this stuff, or like I said, even an organization as big as Driscoll's could handle something like this. So.
Okay, actually, I think that's what we had from objective 4. So thanks for everyone and all your input and ideas.
Thanks, Rufus, Christine, Frank, and everybody else for your comments and updates. Let's move on to objective 5. Do we have Kay or Dami? Okay.
Good morning. Good afternoon, everybody. I was looking for, maybe I'm paging the wrong way on the slides. There we go. Okay. All right. Well, today we're going to talk about our plans for the year. And Dami Lola has been leading a national survey of growers. We started this data collection in April of 2023, and we plan to end it in March, but I think we're going to have to extend that to try to collect as much data as we possibly can. Dami Lola is a PhD student, and he plans to graduate in August. And so I think that gives us a few more months to go ahead and collect data. So Dami, are you with us? Would you like to talk about your methodology?
Thank you, Dr. Kelsey, and I would like to say good afternoon, everyone. Thank you so much for the support so far. I would like to appreciate our esteemed growers all across the nation that have actually responded to this survey. It's been wonderful working with you in different states all across the nation. I would also like to appreciate all our co-PIs on this project. For as many people that have been able to visit with in different states, we say thank you for the support so far. So so far so good. The national survey has been going on well, though the response rate has been low. And a part of the observations which I had on the field was the fact that our growers are actually surveyed fatigued, but we're still receiving responses, and we believe that over time this can still be improved, because we actually want to have a robust feedback from growers across the nation to show and demonstrate the impact of all the wonderful work that this research group has been doing over the years. So so far so good, based on the preliminary data which I talked about yesterday, which I presented. The outputs of the research effort has here from this SCRI group has really been accepted by growers, and it's been effective on their in controlling SWD. However, based on the SCRI project, which started about 3 years ago, we are the last the last phase this year. Most of the technologies that have been rolled out are actually some growers, for as many growers that responded, many of them are aware of those technologies, but the level of utilization is low. And I believe part of the things that that is responsible for that is the fact that all these technologies are still not, they're just being rolled out. But one critical aspect that I think we should actually focus on is how we can leverage on the gravitas that our growers and task force members actually have in disseminating this information to growers within their region. I think that's really going to go a long way in helping to disseminate these technologies and strategies to growers out there. So that could really help in boosting the adoption rate of all these technologies, and also in the long run, minimizing the population pressure and also reducing infestation rate and rejection rate as well. So far so good. There's been information that based on the last presentation, that though SWD has been under a controllable measure, but there's still evidences that some growers are still having population buildup. That's part of the impacts that we saw yesterday, as well as larval infestation in their fruits, in their berries, as well as the rejection rate. This year, as part of the activities that we're trying to continue with, we are continuing with our data collection process, which is going to be a mixed method. We adopted a mixed method because we're trying to capture as many data as possible. So last year we had a 3-wave survey that was actually sent out to growers at intervals of 2 months each. 2 months, yeah. So we had 3 waves of survey last year sent out to 30 growers association in the United States, but the response rate, like I said, was quite low. That was below 10% response rate, and we're shooting for something about 1,000 response from all our growers so far. But right now we're still we are a little bit above 10% of that at this point in time, and that includes the data set that I was able to collect early this year from the Great Expo convention in Michigan, and I was able to meet with Dr. Rufus during that period. I was at Georgia, I was in Halma and Savannah. I was able to meet with Dr. Harch. I was in Mid-Atlantic Fruit and Vegetable Convention. I was able to meet with Dr. Caesar then. So we're still looking at going to the NARBA meeting in North Carolina, maybe at the end of the month. And I think I'm still going to meet with Dr. Caesar, in that meeting. So at this point, I would like to solicit the support of our growers, the task force members, and also the researchers that will be having in getting our survey out there, and also for as many meetings that we'll still be holding, we would like to be part of it and see if we can still use and maximize such avenue, to reach out to growers and get some data out of that so that we can have a robust data set at the end of the day, which is geographically representative enough of the United States, and which could actually reflect the impact of this work that we are that this group has been doing socially, economically, and environmentally. So our activities strictly for this year, this last year, is going to be to concentrate on that data survey, on that national survey, collect as much as we can, and also get our qualitative data too from all the observational meetings that from all the meetings that we're going to be having, and archiving and tracking all the publications from this research effort. So far, so good. We've been having wonderful information, wonderful feedback from growers, which are part of which we got even during the last webinar series that we had from this unit, from this group. So I would say we have a wonderful, we've been having a wonderful impact out there, though there's still room to actually improve on that and do more. So we solicit the help of all and sundry in making this research effort a reality, and in bringing the fruits of this work, out there for people to actually see, and even to the funding agencies. So I would like to stop at this point in time to ask if there's any questions. I would really want to take that at this point in time. So I think one thing I would like to say is this year we're going to be releasing a whole lot. We hope to produce 3 journal articles from these the work that we've done so far on this serving as the evaluator for this research group. We'll be having one who is going to be a qualitative study. We will be having one which is going to be a mixed method, and we're going to be having one, which is going to be a quantitative study from this research effort. And we're going to be having the last report submitted to this unit by May. Thank you. Okay, so we have our survey QR code there that if anybody wants to take that, you can take that picture and even share with anybody at any point, with any grower to take that survey at their own convenience. And if you need the hard copy, we can equally email the hard copy to you that you can easily print and send back, share with your growers at your growers meeting and send back to us when you're done. It's a mixed mode method. We're adopting this method to capture as many responses that we could get. And I would like to say a very big thank you for all your support so far.
Dami, okay, I have a quick question. Do you know approximately how long does it take to complete this survey on average?
Yes, on the average, it takes about 15 minutes to complete the survey. And it's, except for a few questions that which are qualitative, where we actually need the actual feedback. Every other thing is more of a check thing.
As I mentioned yesterday, I will, at some point this evening or tomorrow, I'll reach out to the national program leader for SCRI to see if we can rebudget some funds to incentivize stakeholders who fill out the survey and see what they say. If they agree, we will allocate some funds to give incentives for each stakeholder who completes this survey. So if we go that route, Kay, based on your experience, how much would be sufficient per survey, per complete survey?
Well, I'd like to ask the stakeholders who are with us now, would you prefer an individual incentive of $5 to $10, or would you prefer a chance to win a gift card for maybe $100? Which one would be more exciting?
Both.
Okay. Jimmy says $5 for everyone. I think we have to give at least 7 because a Starbucks coffee is now $6.
Oh, let's round it up to 10.
I think they will be better and more acceptable across board.
I see an individual larger card. Thank you. Any other opinions about what would it take to get folks to complete the survey? We do appreciate that folks are surveyed to death. Every phone call I have with a vendor, I get a survey immediately after to fill out. So it's becoming a bit burdensome. But what we're really trying to accomplish here is to tell a story, particularly to the funders who have invested in this project, about the impact that you all have had on this collective project and about what you've learned and how you've grown over the last 4 years. And we want to be able to communicate that to future funders. You know, we've talked a little bit today about how this project is almost over and where do we go from here. And the results of this survey can help point the direction and can help this particular team secure more funding from the government to continue the work that they're doing, if that's what they're headed. Or it can help another team prove and document that this project has really had a significant impact on addressing the pest and addressing grower behavior to adopt some of these techniques. And so what we're asking is, what have you adopted? What have you learned from this project? How has it changed your financial well-being and your financial outcomes? And so that's why we would like for you to take your time to share that information with us. And we appreciate that.
Yeah, you wanted to say something.
Oh, no, I was just gonna, I put it in the comments, but you know, past things have done just a $5 card for everyone that fills out the survey, and I think that's more than sufficient for filling out a survey. I would hope that growers would want to fill out the survey so that the researchers actually have the information they need, but if there needs to be an incentive, I think $5 is sufficient.
Thank you. Any other comments or questions? All right, if we have no further questions, then we will move on to part B of Objective 5, which is extension and outreach. As I pointed out yesterday, all members of the team are involved in this objective because we all have research and extension appointments. We do meet with our stakeholders regularly at the small scale, at the state level, at the regional level, as well. So we all will continue to present what we learned from our research and extension efforts. And we'll continue to share any new information that we learn with stakeholders as it becomes available. at the end of the project, we will have some extension publications from at least one from each objective, especially objective 2, maybe more than one, which will be crop specific interactive decision aid tools. But other objectives will have at least one extension publication that we will run through either UGA or other participating institutions. And once it's published, we'll share widely with the stakeholders. And at this point, we'll just leave the floor open for any comments or questions from stakeholders related to any of the objectives that we have. At this point, I guess everybody should be able to speak and share their feedback, comments, any suggestions in terms of future direction that we are headed in these objectives or objectives not included in this project. Because this is our last year for the project, eventually we will need to discuss the plan for our team moving forward. We may go into, direction of submitting another SCRI project. We don't know what the focus will be right now, but your feedback will again be very helpful in setting the direction for future of this team and research related to SWD management.
Or Ash, you could take it, the team's done such an excellent job of explaining everything that this is a perfect project, and another SCRI along this way would be a great thing.
That's where I'm headed, I guess. As always, our team has done an outstanding job in terms of connecting with stakeholders. Whatever we learn, we always share that instead of the most efficient way, because we all work very closely with stakeholders in our states. And we always present our information in a very organized way. So that's for sure. And at this point, if we don't have any comments, I guess we have completed our agenda items. At this point, our action items for our team are, especially for the objective leads, are to call at least to one objective-based meeting or sub-objective-based meeting, if that is the case, and discuss plans that were presented today, just to fine-tune and basically firm up the plans for this coming season. And we are good to go. Thank you again very much, especially the stakeholders who joined us yesterday and today. We really appreciate your interest and your feedback to our research and extension efforts. That really helps us a lot.
Thank you, Ash.
Thank you. And at this point, we stand adjourned.
Thank you.
Thank you, Ash.
Thank you.
And thank you to the whole team.
Thank you, Dr. Ash, and thank you to everyone.
Job, presenters.